Modeling labs often begin with a teacher demonstration and a class discussion, and this is no different. This is the introduction to the main quantitative lab that's part of this charge and interactions unit within the modeling curriculum. And so I'm going to pretend that you are my virtual class out there. I have a balloon hung from a string, but I'll get to that in a minute. I will actually start with the question, what are the factors that you can think of that influence the way that charged objects interact with one another? So at this point, as an instructor, I'm calling on people in the class who come up with various ideas, and there's no bad ideas at this stage. So, I don't know, somebody might say the size of the object that is charged. So I'm going to jot that down. Somebody else might say the amount of charge that I put on something. I could rub the balloon, once across my head versus 20 times, and that should make the amount of charge on that a little bit different. It might be the shape of the object. It might be the material composition. It might be, the distance between the object and whatever it's interacting with. So we brainstorm and we come up with a whole list of things to think about. We're just going to table that for a minute and show you a little demonstration. So I think this balloon, which I got off the ceiling, is still charged, and it definitely still likes me. So it appears to be, but maybe for good measure, we'll just mess up our hair again. So make sure that thing is charged up. Down boy. And then charge a second identical balloon. And I'm going to hold this balloon near the suspended balloon and see if we see anything. So I can observe that even though the suspended balloon is still swinging back and forth as a little bit of a pendulum, it's repelled from the charged balloon that I just rubbed on my head, and I can tell that because the string is now not hanging vertically down anymore. So why do these balloons repel is a question that you should consider. And if I move this closer, notice what happens. So, can I formulate this observation of these balloons into a question that we can collect data for and answer? Clearly, when I'm changing this, the factor that I'm targeting here is the distance between the two charged objects. So in our lab today, we want to study the effect that changing the distance has on the interaction between these two balloons. So distance is going to be our independent variable. Now, what do we choose for a dependent variable? What changes as we change this? Well, if we look at our list, I'm holding the size of the object, the shape of the object, and the material composition of the object constant. I'm assuming that the amount of charge that I put on the balloons is staying pretty much constant. So these are all being held constant, and I don't expect them to change as a result of this. What I do observe changing is either the angle that the string makes there. So I could add that to my list specific to this particular experiment. But angle of string, as some of you may be thinking, is actually highly dependent on the amount of string I have here. I don't know, I have less than a meter, a couple feet of string or so. But I would expect that if I actually hung that string all the way up to the ceiling, the angle that I would be measuring for that string would be different. So that seems to depend on the length of the string. What shouldn't depend on the length of the string is the amount of push that this balloon is giving this balloon in the opposite direction. And that is, of course, the electric force or electrostatic force, whichever you prefer. I'm going to call that the electrostatic force. And so out of those lists of variables, for this lab I'm identifying two things, the distance and the electrostatic force, that I want to study the relationship between. So my main question for this experiment becomes, what is the relationship between the electrostatic force experienced by a balloon and the distance between that balloon and a charged object, which in this case is a second charged balloon.